Good morning. I'm going to take a few minutes and review the Chapter 2 Connect homework. The first thing that we're going to do is we're going to look at this problem that says find the average of the monthly productivity figures in terms of units per machine hour. Just a couple of things about the way this problem is set up. One is that you cannot just add up all of the outputs and divide it by the total number of hours, because that's going to give you a smoother picture of the productivity. There's a statistical issue with finding a monthly average. We need to average the month. We need to find the value for the month of January, find the value for February, find the value for March, and find the value for April, and then average those four. If we just take the total, we can lose some of the highs and lows that we might see from one month to the other. So again, that's a statistical issue with why we need to do it a month at a time. Okay, so what I'm going to do is I'm going to go ahead and open up an Excel file, and I'll go ahead and put that here. And I'll blow this up just a little bit. And I have already copied and pasted this in to an Excel file. So I'm going to go ahead and just move that over. All right, so here is the information that we were presented with, right? And so if you remember, productivity is equal to outputs divided by inputs. So in this example, our productivity is going to be equal to our total number of units produced by month divided by total machine hours by month. So we don't need to make any changes, right, to the units produced, but we do need total machine hours. And to get that, we simply multiply the hours per machine times the number of machines. And once I do that, I can copy it over. And then I can say that my monthly productivity is equal to, again, outputs. So 2,300 units produced divided by total machine hours, right, for the month of January. And I can copy that across. Then to get for the average across the 4 months, I average those four values. And if life is good, I can come here and I can say, oh, look, it is 2.06. So we've completed that problem correctly. All right, let's look at the second problem. The second problem says, let's find the labor productivity for each car. So we have a deluxe car and we have a limited car. Those are the two different models of cars. Okay, and it gives us the quantity sold and the price per unit and the labor hours. So what we're going to do, pardon me, is we're going to copy this information into Excel. So I've just opened up a new tab here. And I'm going to just make the font on that a little bit bigger so that we can see it. And just kind of come back here for a second to say, we are after, by model, so deluxe and limited, we want units per hour and units per dollar, right? So let's go ahead and so units per hour is relatively straightforward because we have the total. Again, productivity is output divided by input. So for the deluxe car, right, we have 4,000 divided by, that's the output, divided by the deluxe labor, which is 20,000, right, which is 0.2. And for the limited, we have 6,000 units sold divided by 30,000 hours, which is also 0.2. And I inadvertently labored this units per dollar, and basically we're going to compare dollars over dollars here. So what they're asking for is saying, okay, I need to know the total dollar value for output divided by the total dollar value for input. Okay, so in order to get that, what I can do is I can take 4,000 units sold times $8,000 per car, right? And I can format that as dollar signs with 0 decimal places is what I'd like to do. And again, I can get the dollars for the output for the limited car, right? I can continue to drag that down to get labor hours for the deluxe car and labor hours for the limited car. So to get my productivity in dollars, I'm going to take the dollars of output divided by the dollars of input, right? And again, I can copy this down because those are both relative. And we can see that my productivity for the limited car is actually slightly higher. And so let's just do a quick comparison. So we have 0.20, 0.20. We're good on both of those. We have 133.33 and 135.71. So we're good on both of those. So this is just when we look at it in terms of dollars, we need to make sure that we have total dollars of output divided by total dollars of input. The next problem basically just wants us to look at different types of productivity, right? So we have, if you remember from lecture, we have 3 different types of productivity that we're looking at. We have partial productivity, which is outputs divided by one type of input. Okay, so in part A, where it says, let's look at labor productivity, that's a partial productivity figure. So what we're going to do is we're going to look at, in the US, we're going to look at output, which is going to be sales units, divided by input, which is going to be labor hours, right? And we're also going to look at capital productivity as a, again, that's a partial productivity calculation, because partial says we're using one input, right? So we have total output divided by one input. So if we come down here, we can see basically what they're doing is they're saying, okay, in terms of US, it's 100,000 divided by 20,000 hours. So that gives us our productivity. In terms of the less developed country, right? We're still, output is 20,000, labor units are 15,000. So we've got 20,000 divided by 15,000 is 1.33, okay? And then capital equipment, right? 100,000 divided by 60,000 gives us 1.67. The lesser developed country, 20,000 divided by 5,000 gives us 4.0, okay? So what we're trying to just express here is, what's the difference between partial productivity, multi-factor productivity, and total productivity? Okay, so multi-factor productivity says I'm going to use both. I'm going to use more than one input, but not all inputs. Okay, so in this example, we're going to use labor and capital together. Okay, so in order to do that, we say my input hours for labor and capital together are 20,000 plus 60,000, giving me 80,000 input hours. For the lesser developed country, it's 15,000 plus 5,000, giving me 20,000, right? So again, these are just examples of where we ask for different types of productivity calculations. On the exam, you're going to need to know the difference. You may be asked for partial productivity calculation, and you're going to need to know if it says, I'd like a labor partial productivity calculation, labor is the only input that you will be using. If you're asked for a multi-factor productivity calculation using labor and capital, then you use both of those, okay? So that's just all we're trying to get to with that. I don't really see the need to walk through the calculations in Excel because it's exactly what we've done on the previous tab. But I do want to show you this difference in when we calculate a change in productivity, okay? And so a retail store had sales of 45,000 in April and 56,000 in May, All right. So while we're doing this, I'm just going to go April, May, 45,000 and 56,000 in May. The store employs 8 full-time workers, and they work a 40-hour week. And in May, the store, let's see, in April, the store also had 7 part-time workers at 10 hours a week. And in May, the store had 9 part-time workers at 15 hours a week. Okay. So using sales dollars as the measure of output, what is the percentage change in productivity? All right. So let's take a look at how we would calculate this. This is their hours per week. And this is their part-time workers and hours per week. So this is our output, right? And our input needs to be the sum of the hours of our full-time workers, 8 times 40, and I have that in parentheses. And I'm going to add to that the hours from the part-time workers. So there are total hours. So our productivity is going to be equal to our output divided by our input. Okay, so to get our change in productivity, you need to think about how this should work. So what we want to do is we always want to take the older time period minus the newer time period to show the difference in productivity, right? Because if the older time period, let me think about this, if the older time period, I'm sorry, I have that backwards. We want to take the most recent time period minus the older time period, right? So in our case, we want to go equals May productivity. Let me just, this is just gonna, all right. And let me go ahead, for the purposes of this, I'll put this in because this is going to be the numerator in our calculation. Oops, get all the way to the end here. And we want to divide that by the older productivity. Right now, the reason that we do newest minus oldest as the numerator is because think about it this way. If we want to show positive productivity change, if we have an increase in productivity, right? And so in this example, May has 123, April has 115, 123 minus 115 would be a positive value. So that would be showing what we would expect to see is a positive change in productivity because May is better than April, right? And we're going to get the percentage improvement, we're going to compare that to April's because that's the changes over what happened in the past. So our change in productivity is going to be May productivity minus April productivity, close parentheses, divided by April productivity, right? And if I change that to a percent with 2 decimal places, it should match what we see on McGraw-Hill. And we're within the tolerance range. We were at 6.67, I think is what we saw. Yep. So that's going to be fine. So we're going to be where we need to be there. So that's the 2A homework. I hope that you find that helpful. Some of you may just needed a quick refresher on one part of it, but that should do it for the Connect 2A homework.